explain the next work, which is the preparation of graphene and quantum dots from graphite and black carbon by a liquid phase exfoliation green method. First of all, we know that graphene and graphene quantum dots are materials with a large number of incredible properties that can be applied to the areas of science and technology. One of the problems is that many production methods use substances that are harmful to the environment, in addition to not being effective when mass production is sought. For resolving this problem, one of the techniques with the greatest future to achieve the goal of large production of graphene is liquid phase exfoliation. It's a method where we use as dispersant ascorbic acid and terephthalate were used to try to exfoliate graphite and black carbon, a compound produced by burning times which contain different allotropic forms of carbon. We also studied qualitative desample without desonification. This makes an interesting result comparing to those that receive. For the methodology, we can see in the figure 1 the procedure followed for the synthesis. We first mix all the compounds in water, and after that we use sonification for some time. Finally, we use centrifugation. We have two samples, the sample G, which is the one that contains graphite, and the sample CB, which is the one that contains black carbon. The first thing to notice in our samples is that as we increase the time of sonification, we get a more dark sample, which has the meaning that the graphite and the black carbon are being solubilized in the aqueous media, which is water. We also can see after centrifugation that our samples present fluorescence under UV light, and we also can see an elemental analysis of the sample, which, as we can see, it contains more carbon and oxygen, which it was the expected result. We also can see the IR spectrum of all samples and the UV spectrum. As we can see, the IR spectrum, they are very similar for the two samples, the sample G and the sample CB, which it has the meaning that they have similar functional groups, indicating that the two methods, the two samples are very similar. And the UV spectrum, it says that the maximal absorbance is in the range of 280 to 300. It's a maximum that is very present in the carbon quantum dots and the graphene quantum dots. We also can see in the C image a TEM image, and we can see that it's very clear the formation of nanoparticles in our samples. Finally, we study the samples without sonification. We can see that as we move the excitation wave number, we get a different PLA intensity. This is a characteristic that is very common in the carbon quantum dots and graphene quantum dots. Finally, we can conclude some things. It is possible to do the synthesis of graphene quantum dots using the LPE method. The presence of these dots was confirmed by TEM analysis and size at 4 to 5 nanometers. Graphene quantum dots have luminescence in the range of 280 to 400, but better results are for CB, 286 nanometers, and for G, 290 nanometers. However, more comprehensive studies are mandatory to fully understand the nature of this combination within our samples. Additional characterization steps are planned to unequivocally establish the existence of quantum dots in our material. Here are some references of this work. Thanks for your attention.